We're going to be pushing the envelope, attempting to install the highest weather station in the world to improve our understanding of weather patterns and climate change in the Mount Everest region. These high mountain regions are changing faster than other places around the world. The highest elevations are actually believed to be warming at faster rates than other lower elevation regions.
The point of this conversation, the reason why I emailed you originally, this has been a wonderful intro to it, is that I was at a meeting and someone was presenting, and they were presenting a model, and they were talking about just like weather changes around the world in mountain regions, and they weren't emphasizing this point, but their model had a result that they were modeling rainfall at 6,000 meters. And so someone in the audience, when they got done, just asked, like, is that reasonable? Does it rain at 6,000 meters anywhere? And the audience, we all were talking about it for 5 or 10 minutes. And the reality was no one really had an answer to that question. Like, how high does rain actually fall on the planet? I know it can rain in the atmosphere, and I don't mean that. I mean, where does liquid water get to the ground?
Right.
In mountains, and just like from your work, how high do you think it rains, or how high do you know that it rains around the world?
Yeah, no, that's a great lead in and a great topic. And I had tried to get to that mountain climb meeting, but it overlapped with a National Geographic event that we were doing in Peru, and I just couldn't be in two places at one time, unfortunately. So I'm sorry to miss out on that, but it's a great question. And I think there's a couple ways to approach it. Clearly we know, like in a tropical cyclone, it's raining up to some extreme elevations. And there are, probably some places in the world, and, Southeast Asia and portions of the Himalaya could be one of them, where we have landfalling tropical cyclones, and it's theoretically possible to get some pretty extreme values, some extreme heights where rain can occur, but we just simply don't have enough observations. And in fact, when we talk about precipitation gauges, I think I'm still correct in saying that the one we installed in Peru on top of the Calcaya ice cap at 18,500 feet or so is the highest precipitation gauge in the world. I'm not aware of anything higher. It's possible there's some groups that may have done something more recently above that. And then, of course, what we have at Everest Base Camp, which is 17.6, is one of the higher, and really quality observing stations. This has a weighing precipitation gauge. It has a Parsifal present weather sensor that gives us with pretty high confidence the phase of the precipitation, whether it's rain or snow, or mixed rain or snow, or even tells us whether we're getting graupel, which is fantastic.
That's really cool.
And so these are some of the first data sets that we have. And the problem with and there's Chacaltaya in Bolivia too, which is one of the stations that I set up in 2014 with the NSF grant, and it's at 16.9 or so.
Yeah.
And so those are some points of reference. And when our French colleagues started working at Chacaltaya in Bolivia in the 1980s, 1990s, they didn't have any direct. They didn't have a Parsifal at that time that could distinguish, but it didn't rain. I mean, from people that worked up there, from the measurements they had, snow was the precipitation that fell. That is not the case anymore. I mean, at Chacaltaya, we're getting, depending on the year, 30, 40% of the total precip is now likely falling as rain.
Yeah.
And again, I don't have the exact numbers for you because they change from year to year, but that's a paper, kind of a paper in progress. And this is pretty. That's a dramatic change in the
Yeah.
Andes. When we installed the station at Everest Base Camp, I mean, again, I hadn't spent much time in Nepal, and didn't have tremendous familiarity with it, but um, certainly in from the previous work that had been done at Pyramid and other places, still expected that the bulk of the precipitation, especially at base camp, 17.6,
Yeah.
that there'd be primarily snow falling during the monsoon. Well, the first, year of measurements in the monsoon, it was very apparent that the bulk of the precipitation was falling as rain at
Yeah.
base camp with
Wow.
temperatures in the mid 30s, kind of mid to upper 30s. And
Yeah.
this is at
Yeah.
17,600 feet, where there's the Khumbu Glacier's right there, this massive glacier, and the bulk of the precipitation is falling as rain. And the most recent data that we had, I think from 2024 last year, showed that 70% of the the precip was rain
Yeah.
at base camp. And so it really, I mean, I have to say it surprised me. And and so then that raised the question, okay, well, how high does it actually rain?
Yeah.
And again, we don't have direct observations of that. There, in the Andes, in Bolivia, in Peru, I mean, we've got the station at Calcaya, and there are some periods in there. We only have 1 year of observations from a Parseval. This Parseval just did not work correctly up there, so it's just mainly the precip gauge, and I think there are some cases where it's probably rained at the summit of Calcaya at 18,500 feet or so, but it's very rare, very, very
Yeah.
uncommon. And so I think it's safe to say, at least in the tropical Andes, that above 18.5, 18.6,
Yeah.
probably 19,000 feet is the upper limit, at least in Peru and Bolivia. But now in the Himalaya, it seems like that melting layer, that snow rain transition is higher because of what we see at base camp. And um, it's quite likely that it does rain up as high as 6,000 meters.
Yeah.
Um, and I'm co-advising a PhD student at the King's College London with my colleague Tom Matthews, and uh, he's got some work in progress that, again, no direct observations, but we have lapse rates during precipitation events, and that it does kind of confirm the high probability that in some cases it's raining up into the Western Cumb on Everest, up over 6,000 meters.
Yeah.
And then I've got another anecdote for you. Last year when I was on Everest, I met a guide who, with very high confidence, reported rain at 6,000 meters. I believe it was on Ama de Blanc on another peak
Yeah.
in the Himalaya. And so that was a high confidence report there. But one of the things we want to do, and maybe this will happen next year, is to actually instrument Camp 2. We've got a weather station at Camp 2, but there's no precipitation sensors.
Yeah.
And so and we have no idea how much precipitation is falling up there. I think it'll be a stretch. That's at 6,400 meters
Mhm.
to see rain there, but it may not be far away under the right conditions.
I'm glad I asked you this question. It's fun to go to the
Mhm.
people that actually can answer these
Mhm.
questions with some
Mhm.
confidence. Sounds like we know that it rains up to mid 18,000 feet, which is like 53 5,500 meters, something like that.
It's 55,
Um,
56. Yeah. And
yeah,
then
and
probably
then
up to 19,000 feet, just
yeah,
over, 19,
because
start to get up to
6,000 meters is
6,000. And
around 20,000 feet. It's getting closer to that.
yeah. And
Yeah,
then there's and in the Himalaya, I think with high confidence, we can say it likely rains
yeah.
close to 20,000 feet at
But
times. Yeah.
this gets at one of the big kind of reasons for your work and the reasons for why a lot of us do even simple data collection in mountain systems because we just don't have many observations from most of the world's mountains for much of anything.
Yeah.
And so that I guess is a we what we've censored is incredibly interesting, it sounds like from what you've done, and it doesn't fit with maybe what you would have expected. And that to me is like another reason in a laundry list of why it's important that people like you keep going out and trying to get data from these places because they're just such a big part of our world and how our world works. And they're a black box.
Yeah, and let me add too, with this question of how high does it rain, it's not just an academic
Yeah.
um, question. It is interesting, and it is there is an academic component to it that I think we like to nerd out about and discuss a
Hmm.
little bit. But it has huge practical implications, whether it's raining or snowing up at these elevations. In Peru in 2019, yeah, I think it was 2019, there was this massive glacial lake outburst flood right above Machu Picchu that damaged some of the infrastructure downstream. There are not a lot of people that live there, but it turns out that it was likely raining up at elevations where rain has just not existed
Yeah.
before. And that combined with just the overall warming degraded the permafrost, and boom, you get this massive rock avalanche and rock slide into a glacier lake that creates a small, a tsunami that overtops the moraine dam, and it drains catastrophically.
Yeah.
If it's raining up at these extreme elevations where it's never rained before, that means instantaneous runoff. It means lubrication for these surfaces. It magnifies other mountain hazards. And so there are pretty significant implications for not only, understanding and modeling kind of where this is happening, but then having the direct observations for the early warning systems to provide guidance to um, stakeholders downstream, communities and stakeholders downstream, when actually a heavy rain event is developing at extreme elevations, because that magnifies the hazards and risks in these other areas. And so that
Yeah.
I think that's a really important point
No, it
to
definitely
make
is.
here too.
The we all live downstream component of this
Yeah.
is I mean, a lot of the world's population lives in meltwater paths and relies on what happens in mountain systems, even if they feel very far or disconnected from those
Yeah.
places.